Hi, so today we're going to be going over a board that has no backlight. It is pretty nasty and corroded, and I'll show you what it looks like under here. This is after an ultrasonic cleaning. It is not good looking at all. So you got these two pins that are not even connected anymore. It's just a bunch of blah. You got a pad here on the boost IC, the LP8543. That's just nasty looking. And yeah, this is not a good looking board. Yeah, it's disgusting. Now, one of the things I want to check for before I even bother doing any other work on here is to see if there's a short to ground on the backlight rail. A lot of people, they say, it's a short. Oh, it must be a short. But they don't actually know what a short is. And this kills me. It's just people's universal way of saying this doesn't work. So, let's take a look and see if we have a short to ground, and I will explain what that is. So, if you look over here on the screen, which I will have to move the camera so you can see, you will see that in addition to the fact that my PDF reader decided to stop anti-aliasing because it's a piece of open source crap that just decides to do that whenever it wants, let me show you how this thing works. Let's show you how this thing works. So, because I want you to understand what I'm saying when I say short to ground, so because maybe some of you don't actually know what I'm saying. Alright, so ignore the fact that this is not anti-aliased. So, I'm not going to get into a lot of electronics theory here, but you can have an abundance of protons or an abundance of electrons in one area, and having an abundance of electrons or protons is what makes something positively or negatively charged. Nothing likes to be positive or negative. In the world of electricity, everything likes to be neutral. Think of being positive or negative as being stressed out. Nobody wants to be stressed out. We want to be relaxed. Neutral is relaxed. Positive or negative is stressed out. Now, you need to give these extra protons or these extra electrons a path to go to so that something can become neutral. And it's through manipulating electricity when it doesn't like being positive or negative. It's through manipulating electricity that we get electricity to do what we want. It's very similar to America's foreign policy with other countries. So what we do here is, this is a backlight DC to DC boost circuit. So we have 12 volts coming in over here, and it goes to this inductor. Now, I'm not going to get into how an inductor boosts. You can look for DC to DC boost converter on YouTube, and there are many other tutorials explaining that. Point is, you have 12 volts coming through here. You have one section over here where 12 volts comes in on here, and you also have a 5-volt power supply somewhere over here that sends power to this chip. And what this chip, the backlight boost, the LED driver does, the LP8543SQ, is it creates switching over here, and it slowly shorts this inductor to ground every now and then. By doing this, it winds up making the inductor take the 12 volts and turn it into 17, 19, 20, 30, 50, whatever it is that it needs. Now, again, getting electricity to do anything is about having a complete circuit. Having a complete circuit means having ground at some point in the circuit. So over here you can see this is ground. I mean, you probably can't see because the PDF reader decided to stop anti-aliasing because it is an open source piece of shit. But over here you see ground, ground, ground. Now, let's say this chip happens to die or blow up in some way. Now, a short means that the circuit is shorter than it is supposed to be, right? So this circuit is supposed to take 12 volts, go over here, boost it through what this chip is doing, and go all the way out. But if this chip dies, and this chip somehow internally breaks and jumpers the voltage in to ground, now, instead of the power getting from here to here, it stops over here because this chip, which is going to ground, has jumpered it. And since it's jumpered to ground, it is now short. Instead of going all the way across long, it's going to here and then stopping and going to ground, which is short. So one of the ways you can check for a short to ground is to simply measure using resistance mode or diode mode on your multimeter. Resistance measures the resistance, or how much resistance there is between point A and point B in a circuit. Diode mode measures the voltage drop across 2 points in a circuit. It's pretty much the same thing, except diode mode is much, much faster. So over here we can see at the end of the circuit is C9797, C9799. Now I know where to measure those because I have done this about 50 billion, million, trillion times. So just if you don't know where that is, I'll show you on the microscope. This is an 820-2530 board, and it's right by the speaker microphone here in the DCN board. So let's measure. So I put the red probe of my multimeter on ground while it's in diode mode, and I put the black one on one of the sides of this. I forget which one it is. Alright, so that side must be ground because it's 0. And this side over here, I get 0.554. That means that there's a 0.554 voltage drop to ground, which means that there is no short to ground. If there, for example, if it was shorted to ground, I would get something like this, which you probably can't see, which is 0 on my multimeter. So right now I see 0 voltage drop to ground on my multimeter. A 0 voltage drop to ground means that it is shorted to ground because there's a 0 voltage drop. But when I go on the backlight side, I see 0.554 on my multimeter. And since I see 0.554 on my multimeter, that means that there's no short to ground, which means it's safe to continue. So one of the reasons it's important to check that is because a lot of people will actually go to the trouble of replacing a fuse or replacing a connector and doing all this stuff without actually seeing if there is a short to ground. For example, a fuse in the circuit will blow if too much power is going through it. Ground is a place where electricity will always go with no resistance. So when you have a ground, it's pretty much like, it's like dropping somebody out of an airplane. I mean, it's not like they can't go any faster if they were running and try. They're going to fall as quickly as possible, and it's going to be painful. It's the same when you send electricity to ground. There is no limit to how much electricity can go to ground. So if a circuit has the ability to provide this much, it's going to be trying to provide that and then some, because you're feeding that into a load that has an infinite capacity to take electricity. There is no resistance, and that's pretty much how that works. So if you are replacing a fuse, one of the things that you really should do is check and see if there is a short to ground. So I'm going to be replacing this connector first things first, because obviously it doesn't even conduct electricity, so why would I leave it there? Now, one of the things that makes me sad is that I did want to do a video showing you how to use drag soldering. So a lot of people have been asking about it. I was going to do it for a video instead of doing point by point. And this is not an iron that's really made for that. This is the FM 2027. I used to have the Weller WMP65, which was a much better iron for that type of thing because it was a micro pencil. This is not a micro pencil. It does the job. I can't complain. It does the job. But I did buy this thing for the intention of using it to, clean up BGA sites. I didn't buy it with tips that I would use for micro soldering, so it is missing a little bit in that department. So, alrighty. Let's. Alright, so my Hakko FR801 rework station should be hot enough by now that I can get to taking this off. Now the first thing I'm going to do is clean off all the junky lead-free solder that's there with some leaded solder. Unfortunately, this solder does not have the flux in it that I like. I can't actually find the one that has the flux in it that I like. I'd actually have to go and buy every single Kester on Allspec, which I haven't gotten around to. I've had this solder spool for a good 6 years that I loved, and I honestly don't have the email that said which one I got. So, yeah, first things first is clean up all the old leaded-free junk. Lead-free solder is honestly fine for production of most things. It's just that it's annoying to work with when you're actually reworking it manually, which is why I prefer to just pick up all the old lead-free stuff. I'm not one of those people that says I'm reballing every chip that I work on with leaded solder balls because lead-free sucks. I'm really not a fanboy one way or the other. I use what's easiest for me. And here I find that lead-free solder is a pain in the ass, so I do what I have to do to make it work with what I have. So, now I'm going to use a desoldering iron to get rid of the gunk. See how close this thing can get. Yeah, not too close, unfortunately. Oh well. I'm sorry, you won't have a perfect view. So I let it heat for a second or two, and then I hit the button, and then I let it naturally move along. I don't want to drag it because I don't want to mess up the pads, so I don't use my arm or any of my own force. I only use the force that's generated by the motor of the actual thing to vibrate it along. And I also give it time to heat. So let's see what I got under the microscope. Could be cleaner. So after I do that, I do my final cleaning with some wick. So I got my wick. This is supposed to be a ball, and somehow this Hacko thing that I got turned into an egg. So it doesn't want to stay put. Like, look, it picks itself up with the iron. It's driving me nuts. This is the wrong tip to use to be using the wick, because it's very, very fine, so it's not really going to get a lot of the job done, but it is so clean already that it will get the job done. Now what I'm doing here is I'm scratching away the oxidation on one of the pads for backlight. This is 30, 29, 28, 27, 26, 25, 24, 23, 22, and 21. So 22 and 21 carry the backlight. And as you can see, pad 22 is kind of nasty and messed up. So I'm scratching away the oxidation. I want to get to the copper trace on the board so that I can solder to it. There we go, so we got a nice big pad there for me. Now we get ourselves an LVDS connector. Let's see if I can do anything even remotely close to drag soldering with this huge tipped iron. I have my doubts, but anything's possible. So the older connectors are a bit more of a pain in the ass because the older connectors, they have a funny way of staying on the board. They don't have these things under them that the new ones do that kind of keep it in place. So there's these holes in the board, and the new connectors have these little pegs that stick off of them so that when you put it down, it won't move from left to right as you place it. This one doesn't do that, which sucks. I know, I'm complaining about trivial stuff, but it makes a difference to me. So, like, watch, I mean, for people who have unsteady hands like me, as I'm holding this down, it's actually going to start moving. Like just putting the tweezers down so that it doesn't move when I put the flux on. So flux is what allows solder to flow. You're not supposed to keep the solder on the iron and then let all the flux burn away that's inside the solder and then touch the solder to the point. That's not how this works, because if the flux is not there, the solder won't flow and the joint goes to crap. But here, I'm out of hands to actually do the work. You know, I need to hold the connector with the tweezers so it doesn't move like this crap, as you can see. And I need to hold the solder with the other hand, which means that I'm out of hands because I would need another hand to add solder. So I add the solder to the iron. I should be saying solder, but it's just, I don't know. I'm so used to saying it the wrong way that it's just probably never going to change. So I should be adding the solder. I know. Troll me on YouTube. I will happily ignore it. Anyway, so I'm used to adding it on the tip of the iron, which is technically the wrong way to do this. I add a little like this, and then I touch it to there. Because, again, I have one hand for the iron, and then I have one hand to hold the thing onto the board. So, this really is just a question of being out of hands. Like, there's not much I can do here. So, this isn't going to be perfect. I just want to get it stuck to the board without getting solder in the front. Because once you get solder in the front, you are screwed. Like, it is a miserable pain in the ass to get the solder out of the front of the LVDS connector. So when I say out of the front of the LVDS connector, what do I mean? So see over here where you plug the actual cable in? So if you get any solder over here, the cable won't plug in. And getting the solder out of that area is an absolute effing nightmare that you want nothing to do with. So I got that side done. Now I want to get the next. Now the important thing here is to make sure that it's actually pushed down, because if the pins are not touching the board, making those solder joints is going to be so much more difficult. I really should just start saying solder, but I don't know, I can't. It's like, I just can't. I like solder better. It's wrong. It's so wrong. I don't know. You say something a certain way long enough. It's like all these people that say, I want a lamb gyro at the stand. It's a hero. It's just, you know, they've been saying gyro for like 16 years. Good luck getting them to say hero. See, watch. I'm going to push it down because those pins, they have to be making contact. If they're not making contact with the board, the job is going to be that much more, infinitely more hell. And again, making this perfect in the beginning is not my priority. Making this stick down, I want it to stick down, but I want it to not get any solder in the front, because if I get solder in the front, it will be just a complete mess. And again, removing that is not any fun. So I just want to avoid that completely. Alright, so now we're going to go along. I put flux in there because it will help the solder stick. And we're going to go one by one. Make sure the iron is nice and clean. So we go here and we do pin number 1, right? You know, one of the things that makes this easier is to put the board sideways. I'm awful at soldering connectors. It's just, I am bad at it. So I usually go by one, and then I start to do wave soldering. I start to do drag soldering once I get a short. So here I got a short on my first pad. Beautiful. So, why not? Just give a little bit of a demonstration of how that works. So once you put flux there, which is going to allow the solder to flow, you do something like this. See what I just did there? You see how that worked? I got the solder onto every pad that way. And you really need a good flux to do this. So I'm using Amtech NC-559-V2-TF. That's Amtech, A-M-T-E-C-H, NC-559-V2-TF. There is no other flux. For BGA rework, for board rework, for connectors, there is no other flux. This is the end. This is the good shit. It's expensive, but you need to buy it. Amtech does not pay me. They have just allowed me to make my life that much easier by providing tools that work. And so you'll have to do a little work to actually get this going. You know, it's not really like just slide. Especially, again, this is not an iron that's made for it. If you have something like the WMP65 or a Hakko micro soldering, a Weller soldering pencil like the WMP65, it is easier because it's made for it, you know. And this is not exactly the ideal tip for doing it, but did you see what I just did? It's like zing! Like you go right across and it's just zing. Like zing. Really, truly, zing. Now I have shorts. And you can also tell from the shape that the solder is taking on as I'm soldering it that is a very much so lacking flux. So when it lacks flux, you'll start to see those whiskers at the end, and that general not liquidous kind of junk. So yeah, direct soldering makes this much easier. Again, if you have the right iron, it is much faster, but as you can see, I'm not doing like one pin at a time. It really was just, you know, slide and good flux, and sliding with good flux really did the job for most of the pins. Sometimes I like to actually drag the short over to the pins that I know I can get away with it on. So like on this board, pins 2 and 3, they go to the same place. So if I'm going to have the short, instead of going absolutely batshit nuts to get rid of the solder blob, I just send it to the pads where I know that it's allowed. So pins 2 and 3 on this board are going to the same via. Same for pins 21 and 22. So now what we do is check the work. So clean the board with some alcohol. It's going to make viewing it a lot easier. Get rid of all that flux. Flux is nasty. One of the reasons I haven't gotten the micro pencil for the Hacko is because I'm honestly just so tired of spending money. I mean, like I'm not at a point in my life where, you know, 120 or 130 bucks is going to hurt me. I'm really not. I mean, thank God I'm at a fact where that is just nothing to me. But I spent, I would say, $1,000 on this microscope and the camera so that I'd be able to do these videos. I spent, maybe $7,000 upgrading from the $8,000 upgrading from the Scodel to the BGA rework machine. I spent like $2,000 or $3,000 on the better camcorder, $300 on the television so that it would make it easier for me to point stuff out to you, and, you know, a lot of other small little things I bought this year. So there was a lot of money that I just kind of divested into this project of being able to show you how board repairs work. And at the end of the year, it's like I made money, but I look at what I spent and it's like, oh my God. Like, I knew why I spent everything at the time that I did it, but I look at it now and it's like, dear Jesus. So what you can see what I'm doing here is I'm going over each pin and I'm actually pushing it pretty hard with the single end of the tweezer. And the idea behind what I'm doing here is I want to see if any of these are not soldered properly. If it's not, you'll see it move or come up off the board, or the pad will come up. And so far everything's good except for that one supportive pad at the end, which I will do right now. Could look better. Also, I might as well get this while I'm at it. So I've been over the one-wire circuit and what it is a million times. And on this board, this via always corrodes, and this is kind of nasty looking, so figure I'll be nice and hit this thing before this corrodes and this stops working. It's always good to do the little things that you can do to prevent somebody from coming back to your business. You know, you want people to come back with their next computer, or you want them to come back with their phone after their computer. You don't want them to come back with the same laptop. So, just something to think about. Let's just get all that corroded, nasty junk out of that solder there and just do some fun. Yeah. Alright. Add a little flux to get rid of the short from the 2 pins. Come on. Alright. Okay. Looks good. Now let's clean that junk off. Looking good. I'm also going to go around the LP8543 a little bit because its solder joints look nasty. Very nasty. So, yeah. Some of the alcohol is going to burn away for a second. Alcohol is not exactly a good flux. It doesn't make good flux. I'm going to go over this again anyway, but this will burn away the alcohol at least. Q-tip. The Q-tip left behind some... Ugh. Come on, get off the board. Get off of there. Alright, yuck. It's probably safe to say that the backlight fuse itself is blown. So that's the next thing to check. Oh. I should unplug the desoldering iron before I burn my elbow on it. The fuse is good. Yep, a lot of good that fuse did. A lot of good that fuse did. The pins burned before that thing did anything. Alright, almost time to plug everything in. Looking good. This is just... Where I keep my test parts is made for tall people, so I can never reach it. It helps so much if you actually plug the screen in on the screen end. You'd be surprised how much brighter the backlight is when you plug the screen in on the screen end. It's the little things. The little things. Okay. Alright, so the screen flashes for a moment, and then does not come on. So let's get an idea of why that is. Let's take some basic measurements, shall we? So first thing I'm going to do is see what exactly the power is at backlight output. By measuring on the LVDS connector. That's probably a bad idea when I can just measure off of these caps. Yeah, that makes it easier. So I get 12.6. That means that the voltage is going through completely to the circuit, but there's no boosting going on. This can be because of a couple of things. It could be because of a corroded feedback via going back to the LED driver. It could be because the LED driver itself is just destroyed, which is my guess. Because as I showed you, the pads on it didn't exactly give me much confidence. And it seemed kind of roasted. So let's remove it and replace it with another one. So I'm going to cover the LVDS connector here with some Kapton tape because I don't want to burn my new work. I really probably should have just replaced the LED driver before I did the LVDS connector. Yeah, if I were using my brain, that's probably what I would have done. But I wasn't using my brain, so I didn't. Alright, so let's get an LP8543. I don't use a lot of these anymore. I bought these chips a while ago and I still have most of my spool left. Yes, these do go to a board that's almost 6 years old though, so. I'm not replacing this based on measurements at the moment. I'm replacing it based on what it looked like. It also could be this. Notice that one of my resistors to backlight enable is actually kind of nasty. So there's a 3-volt signal that tells this chip to actually turn on. You know what? I'm so convinced that that may actually be what's it. And I feel so dumb that I didn't measure it. Let me just make that little solder connection look nicer and check that. Yeah, why am I jumping to replacing a chip when something else could be wrong? This is exactly the thing I tell you guys not to do. And I'm doing it. I guess that's what happens when you are trying to repair motherboards on New Year's Eve. But it's going to be New Year in a few minutes. I don't know if this is exciting to any of you people. To me, it's just another day of work. I'm a Scrooge. Okay, so that solder pad for this resistor is non-existent. It's part of the problem. We're going to make it. So we're going to scratch away here. So the whole idea behind backlight enable is that when the 12-volt signal opens to this whole line, there's also a pin on the chip that needs to have C3 volts in order to actually enable the backlight circuit to work. So there's a voltage divider by 2 resistors that takes that 12 volts going into the circuit and turns it into the 3 volts that this needs in order to actually enable and turn on. And those resistors very often get destroyed because they're really small and they're attached to a high voltage line. And that resistor I just took off looked pretty destroyed. So let's see, was that the 301K1 or the 105K1? So I might as well show you that in the schematic. So let's show you that. I can't believe I was this close to replacing what may have been a working LED driver. Wow. I did what I tell you guys not to do. I wasn't using my brain. You see how important it is to never turn off your brain even when it is New Year's Eve? So, over here is the enable pin of the chip. Let's just zoom in a little bit more. So this is the U9701, which is LP8543SQ. U9701 is the number on the board. LP8543SQ is the actual part number from, you know, Texas Instruments or National Semiconductor or wherever these come from. So you have BKLTEN. EN, enable. When there's 3 volts here, you will get the backlight to turn on. So PP-Bus SO LCD backlight power, if this is confusing to you, you can scroll up or just hit Control F and search. That's this 12 volt voltage running along here. This is the 12 volt voltage running along the top that I showed you before, that the inductor is going to turn into a big voltage. So once that voltage is let through by the system, it also creates this 3 volts via this voltage divider to go to the backlight enable pad. So most enable pins on these types of chips, 2.5 to 3.3 volts, not 12 volts. The system runs off of 12 volts. So are you going to create another set of transistors to open and send 3 volts of this every time you want the backlight to turn on? Or is Apple going to spend 5 cents on these 2 resistors to create a voltage divider so that this chip gets 3 volts every time the 12 volt backlight rail comes on? They're going to spend 7 cents and buy these 2 resistors. So to give you an idea of what I mean here, these are the transistors that tell the backlight circuit to send the 12 volts from the system to actual backlight. So this is a transistor. This is going to open based on this transistor. These transistors are going to open based on LVDS, IG backlight on, and backlight PLT reset L. So these signals over here are going to tell the system, take my 12 volts and send me to the backlight and let the backlight turn on. But that chip itself is not actually going to boost without 3 volts at its enable pin. So what do? You make a voltage divider that takes that 12 volts so that every single time that 12 volt rail opens to enable backlight, it also sends 3 volts to the enable pin. So now I have to see which one of the resistors in this voltage divider is bad. If you don't know what a voltage divider is, Google it, YouTube it. There are great little guides. The whole point of a voltage divider is you can use 2 resistors, one resistor going between your source voltage and your destination, one going from destination to ground, and you can take that voltage and divide it. So that is R9731, and that is the 301 kilo ohm resistor. So let's find that on one of my donor boards. So I have a lot of donor boards here, and let's take it off of one of these. See, what is the software you use, Lewis? What is the software? Google it. Google it. Truly. Google it. Google it. Google it. Google it. Not distributing it. Not answering stupid questions. Google it. Google it. Do some investigative work. Yes, you will actually have to spend some money to get this stuff. I know, it's surprising. If you actually want to make thousands upon hundreds of thousands of dollars repairing laptops, you may have to invest $5 or $10 every now and then to buy the tools to do it. I know, life is so unfair. So unfair, man. Yep. No sympathy for you. You have to buy stuff to make money. Same as the rest of the world. Alright. So I'm going to take the resistors off of this donor board, which is a different type of board, but uses the same, pretty much the same circuit. Alright. New Year. Da, 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 da. Thank you. My clutch cover fell right as I was soldering. and then I just burn my finger. This is stuff that only happens in a video. Clutch. Alright. One more time. It's much easier to solder to a pad than it is a via that you've cracked open and shoved solder on. And let's take the other resistor, since if one of those is exploded, you might as well just take both so that this thing doesn't come back. The last thing I do want is for this piece of crap to come back because another resistor died that would have taken me 9 seconds to replace. Holy lead-free solder, that did not want to melt. Look at my Captain tape. My Captain tape is just... My Captain tape got owned. This is where hot tweezers would be cool. I really should get some hot tweezers. I've just been cheaping out. Hot tweezers would be very, very nice to have because there's really no use in hot air for this type of small stuff. It's a waste of energy, and it's also a waste of heating up other parts of the board when you don't have to. So it is truly a waste. I'm just doing it to be cheap because I know I can get the job done this way. I know it's going to be just as reliable this way. The only cost is pretty much my time and my patience. And my time and my patience are worthless to me, so I'll just save the money for the time being. Now, once I decide that I want to start doing like iPhone or iPad board level repair, no, you need tweezers. You're not doing this stuff without tweezers. You do need tweezers. But before then, you really can get away without it. Alright, so that is nicely attached to that via. Let's see if it turns on. We will see. One way to find out, and the one way to find out is to try and plug it in. Also, I have to remember that my other chip was on the board, my other LP8543SQ, so I was this close to just knocking it off the table. Those things are $5, so you know, it's good to not throw it away since it does cost me money. Alright, let's see. Do I have any New Year's Eve luck? Is this going to work? Is this going to work? Do I get light? I'm going to spend a little bit more time measuring this time if I don't get light, so I have an idea. Come on. Okay. What do you know? We have a light. So as you can see, I was being an idiot. I was this close to replacing a chip that actually worked. I was going to replace this chip, and the chip itself was absolutely fine. Boosted perfectly fine. You see what happens when you don't think? I mean, that's why I yell at you so much for asking those questions where you're not thinking. Even at this point in my job, even at this point in my career, I still do stupid shit. I still sometimes just say, I want to replace this, just because, instead of actually looking for the hints. It's you know. It's the same thing when I do those diode mode measurements to ground. It's not just measuring the circuit that makes the diode mode measurement to ground important, is that it's the error correction. Like it gets late in the day, let's say you've been doing this all day and it's late in the day and you miss something. Those measurements will help you to correct your error before you go, I give up, or before you give the problem off to somebody else. Because again, in this business, every time you give the problem away to somebody else, you're giving it away to another repair shop, or you're giving it away in terms of you're selling it as broken at 200 instead of selling it as working at 600 or 700. So it's good to have practices in place where you catch yourself and you do something stupid. So on that last video where I'm showing you that the trackpad didn't work, I didn't check to see that 18.5 volts was there. I checked to see that other voltages were there, but I didn't check to see that 18 was. If I did, I wouldn't have had to do the diode mode measurements. But the diode mode measurements allowed me to catch my dumbass mistake. And the cool thing here is that I caught my dumbass mistake. It really was just the backlight enable resistors. So on this circuit, the issue was that the LVDS connector itself was blown. And in addition to the LVDS, so in this machine, the LVDS connector, was destroyed. You saw that the pins were missing in it, and in addition to the pins missing, I am bad at using a tripod, you also had backlight enable resistors that were destroyed, and the pathways going to the backlight enable resistors were also destroyed. So to go over what we learned in this video, you learned how to check for a short to ground, you learned why a short to ground is important when troubleshooting an electronic circuit. You learned how to utilize drag soldering, albeit poorly. You still had an idea of what drag soldering does, so that you can just go ding and solder every single one of the pins without having to go dink, 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 dink. You just go bring. It's a pretty cool way to do it. I didn't demonstrate that in earlier videos. The Hacko 936 I had, there was no drag soldering with that. I'm telling you, there was not. On this iron, there is. It's just I'm afraid of people ruining it. There are so many attempts that I get of do-it-yourself drag soldering, and this brings up something that Jessa Jones told me one time. She took a picture and she sent it to me, and she goes, "Isn't do-it-yourself micro soldering cute? Kind of like my daughter's preschool artwork." And it made me laugh, but it really is. Like when you see that what people try to do. It's like in the beginning, it's, oh, this guy made my life harder, boo. But after a while, and you see the different creative ways in which people fuck shit up on their own, you just look at it, and it's like, that's so cute. I see what you tried to do. And I see these drag soldering attempts where instead of the legs being straight, they're all like this and they're broken off. Because instead of going zing, they went and they just tried to like get the solder to stick and go all across, and in doing it, they broke it. And in these videos, I am trying to show you ways of doing things where if you are a beginner, you will be able to do it and not destroy stuff. So hopefully you learned something. You learned drag soldering, you learned backlight enable resistors, you learned voltage dividers, you learned what a short to ground is, you learned replacing an LVDS connector, and you learned, above all, to use your brain and not be an idiot.